Hello, Kent. How you doing? One of the few things that I've learned, and is really important to understand, is that there's a freebie that happens when you have a magnet close to a piece of iron. What happens is the magnet has two pressure zones, like a north part and a south part. And if you were able to visualize it, you would visualize tornadoes, one going in one direction, one going in the other direction. When the magnet was made, it was pumped up with a lot of current, electrical current, and that made all the atoms line up. So now you have two inertias, one going one way, one going another, and it remained like that. It solidified that way. So all this energy from around us, which is electromagnetic energy, we live in an electromagnetic world, gets spun around through the midpoint of the magnet and gets tossed out. So a magnet, what a magnet is doing is organizing this disorganization, this electromagnetic energy that's all over, which results in nothing because it's disorganized, but the magnet organizes it into two poles, the North Pole, South Pole, and it organizes into two distinct pressure zones. And the amazing thing about it is it's not normal. Nature is not like that in the normal sense. It doesn't like to have pressure zones. So what happens when you bring an iron bar close to a magnet that has two poles? Automatically, the magnet wants to dissipate its energy. And anytime you put an iron close to it, the magnetism will jump into the iron bar. And not only does it want to jump into the iron bar, it wants to cancel itself out. So let's say that your magnet is here with the North Pole on top, South Pole on here. So you bring this iron bar close to it, and it'll create a magnetic loop automatically. You do not need to put energy into it. Just by bringing the iron bar close, you form a magnetic loop. The north going into the south, south going into the north. And you did nothing except bring the iron bar close. Now, let's say that this iron bar had coils around it. Well, when you do that, and you have this, it's called magnetic flux, this stream current, imagine it, if you will, if it was a current of water. So you got a pump up here, the North Pole, let's say it's a pump, and over here, down on the bottom, you have another pump, but it's a suction pump. So automatically, when you put a conduit, let's say this is the conduit, the metal iron bar, it'll suck into the iron bar and it will go right into the South Pole. Automatically, again, without you putting any energy in. What happens is if this iron bar had coils around it, it would produce an electrical current, electrical energy. That is what you can harvest for free. Absolutely for free. It's there. It's for you to take. And you could do this approaching of the iron bar over and over and over again, and it will constantly make electrical energy every time you bring this iron bar close to the magnet. It will do that automatically. You do not need to do or put any energy into it. It does it at the speed of light, and it's free. So people are looking for free energy. There it is. The problem with the invention of 1829, and we're going to go through that, is that they have like two coils. Look, if you look at the photo, two big coils and a horseshoe magnet that is spun around so that the poles interchange. Every time you spin it, it changes. According to Faraday, every time there's a change in magnetic flux, a change It doesn't say how much power you need. It just says a change, you will produce an electrical current. That's verbatim. That's Faraday's law. Anytime there's a change in the magnetic flux, so every time you turn the horseshoe magnet back and forth, you're going to create electrical energy. Okay, so what is the problem with that? Why don't we just continue getting free energy for forever? The problem in today's generators is they took that idea of the coils and they put it in a circular fashion. So instead of like 2 little coils, now they'd have 8, maybe 16. But what happens is this is just a side effect. Anytime you have an iron core with coils around it and it starts a current in there, that's what happens when you approach a magnet. You're also creating something else besides electrical energy. You're producing an electromagnet. Anytime you get a current going through a wire like this in this circular fashion, that core, that iron core, becomes a magnet itself. It will become the same polarity as the magnet that's coming in. So in other words, the north that's approaching the top will be north. The south that's approaching the bottom will be south. So these magnets they oppose each other. That is what people call Lenz's law. Is there a way around it? Yes. You don't put them like this. You put the coil like this, so that there's no opposing forces. That is, in a nutshell, my invention. You don't need to do this. People have always thought you need to bring the magnet over the core to get this energy to work. You don't need to. Remember, magnetism will go through to the iron regardless of which way your iron is pointed. It will penetrate into the core. That is the key to the insight that I have. You don't need to put an electromagnet against a magnet, which is kind of what we're doing in today's generation, electrical generation. We are facing a permanent magnet against an electromagnet, and we do that many times, multiple times. So I will show you in a diagram what happens, and why this affects the generation. Why generators get so hard to turn, and they'll tell you this. Oh, it's because you're turning muscle. You're turning kinetic energy into electrical power. They'll tell you that, and they want you to believe that. Now all you're doing is taking energy, mechanical energy, and converting it to electrical energy. Well, I'm going to tell you that's bogus. It's not true. The energy that it takes to turn the generator, the opposing mechanism that you have going on, is what creates the resistance. Anytime you have a magnet approaching a same polarity, there's going to be resistance. And that's exactly what you're doing inside a generator. You're creating you have magnets surrounding electromagnets. And I'll go into detail on that, so you can understand what's going on, what the problem is, and how we can solve it. Okay, so that's coming up next.